The Doppler effect is the phenomenon in which the frequency of a sound appears different because the source is moving relative to the observer. It occurs because the source continues to move as it emits successive sound waves. When the source approaches the observer, each new wave is produced from a position slightly closer to the observer than the previous one. This compresses the waves in the direction of the motion, resulting in a higher perceived frequency. Conversely, when the source moves away from the observer, each wave is produced from a position slightly farther away. This stretches the waves produced in a lower perceived frequency. A common example occurs when an ambulance or other vehicle with siren passes an observer. As it approaches, the pitch appears higher because the vehicle moves forward while emitting the sound, compressing the waves in front. After it passes, the pitch drops because the waves are being stretched out. The magnitude of the Doppler shift depends on the speed of the source relative to the observer. Faster movement produces more pronounced changes in pitch, while slower movement produces subtler changes. The effects is most noticeable when the motion is directly toward or away from the observer and less pronounced when the motion occurs at an angle. In summary, the Doppler effect occurs because a moving sound source changes the spacing of the waves it emits. Wave fronts in front of the source are compressed, and wave fronts behind are stretched, which alters the frequency that the observer perceives. This explains why approaching sounds seem higher and receding sounds seem lower in pitch.